Okay, next problem. There is two power series is given. This is F and G. The radius of convergence is F equal to R and radius of convergence of G equal to capital R. So using the Headman's formula, you have to find the radius of convergence both F and G. Okay. So F equal to here an equal to n log n. Using the an plus 1 and log of n plus 1 log n log n. We taking n is common outside and cancelling the term, we get 1 plus 1 by n. Here also we taking n is common outside, 1 plus 1 by n log n. Are you clear? By log of a plus b, using the log of a plus b formula, log a plus log b. This is log a and log b. So log a plus log b divided by log n. So cancelling log cancel, we again we get 1 plus log of 1 plus 1 by n divided by log n. By using the binomial theorem, 1 plus x whole power 1 plus x minus x square by 2 minus plus x cube by 3 and so on. So using this formula, we expanding this logarithmic term, we get 1 plus 1 by n into 1 plus 1 divided by n log n minus 1 divided by 2 n square log n up to etc. Now limit n, applying the limit n tends to infinity, we get this term becomes 0 and the remaining all the terms 0 because 1 divided by infinity is 0. So this is 1 into this is 1, 1 into 1, 1. So 1 by r equal to 1, so r equal to 1. Are you clear now? Okay. Just you have to replay anything because are you there or not? Only I know. Next, the second power series. This is also in z power n. Directly we can take an. Before you have to choose an, your given series is z power n. Z power n is or not. Check whether all the terms, all the problems. So an equal to directly we have here we take n squared by n. Now applying the first formula 1 by n. Here n power will be cancelled. So e power n divided by n. So denominator also 1 by n is there. So already we know note limit n tends to infinity, n power 1 by n is 1. So e power n divided by 1, that is e power infinity divided by 1. So e power infinity is nothing but infinity by 1 is 1. That is the value of 1 by r. So next you have to find value of r. So 1 by r equal to infinity, so r equal to 0. Okay. Are you clear?
Yes, sir.
Don't forget to convert 1 by r into r because the option is infinity is also there. You get 1 by r equal to infinity. Directly you can choose, it is possible to choose r equal to infinity. So don't forget to choose to find the r value. So here option 2 is correct. But you didn't forget to convert to 1 by r equal to r means you have choose r equal to 1, r equal to infinity. So it is wrong. We worked out each and everything, but in the last step you forget to convert into r means you have to choose option C, option 3. It is wrong, but correct option is r equal to 1, r equal to 0. Are you clear what I say?
Sir.
Yeah. Next question. There is some logic behind is there. Here p of x is a polynomial of degree greater than or equal to 2. In last problem, one of the problem greater than or equal to 1. Here p of degree is greater than or equal to 2. The radius of convergence of power series pn into z power n. So here an is nothing but pn, p of n is any polynomial. Okay. Are you clear, ma?
Yes, sir.
So directly you check, take any example. Otherwise you following this manner. Greater than or equal to 2 means p of n equal to, I take n equal to 3. So in the last problem an equal to n cube. So an and an plus 1, an plus 1 and an, then you have to find n plus 1 the whole cube divided by n cube. Greater than or equal to 2 means I have to take n cube. So then we get 1 plus 1 by n the whole cube, then limit n tends to apply, we get 1. So radius of convergence is 1 for all the polynomial degree greater than or equal to 2. So therefore directly we can select the option 2 is correct, isn't it? This is the one of the way. Next, another way is we know the radius of convergence of the power series first one. We without p of n we know the polynomial of degree. Next, and p of n equal to 0 to infinity pn is always same for the polynomial p of x, and the radius of convergence of z power n is 1. Therefore the radius of convergence of p of n is also 1. Can you able to follow?
Yes, sir.
Yeah, just we need to find the radius of convergence without pn, and the multiplying pn is the same for a polynomial of radius convergence p of x. Always we know the radius of convergence of the polynomial is 1. So 1 into anything 1, again we get 1. Therefore radius is 1. Okay. We have to find any polynomial, the radius of convergence is always 1. Okay. So that's why using this manner, but this is your easiest way to finding the radius of convergence. You have to follow this method. Shall we move on next problem?
Yes, sir.
Next is December 2016 question paper. What is the radius of convergence of this? Shall you try?
Sir.
Okay. Just you have to try this. Here what is an?
1, sir.
1. So radius of convergence of this series is what? What is the radius of convergence? What is the radius of convergence, ma?
1, sir.
How? Because your series is not in power series form. Z equal to n equal to 1 to infinity, z power n squared is there. How to say? What definition we have studied? What are the definitions studied, ma? Are you clear now? The property 7, what says that? Z power n the whole power k or nk. A power m the whole power n is nothing but a power mn. So z power nk or z power n the whole power k, whatever may be. Okay, in explaining this property I have said that nk. This is nk or n power the whole power k. The radius of convergence is r power k. You have to find the radius of convergence in your series. Then you have to find multiply the raise the power k. Then you get the original series. But this property is need not necessary to use this problem, because an equal to 1. But an is other than 1 means you have to use this property. Are you clear, ma?
Yes, sir.
So here an is 1, that is no problem. So always radius of convergence is 1, directly you have to put equal to 1. But an equal to differ other than 1, that is differ from 1 means each and every time you have to remember this property summation n equal to 1 to infinity an z power nk or n power k, both are same. The radius of convergence is r power k. Here radius of convergence is r, so power is k is 1, so r power r equal to 1, 1 power 1 is 1. Okay. Okay, if I forget this formula, then how to identify this radius of convergence? Suddenly I don't remember this property. Then how to answer this problem? Any idea, ma? Can you understand my question? In my example, I didn't remember this formula. Some another one an is there. How to find it? How to find it, ma? From 1 to 8, you have to remember all the problems. It is easy to answer this problem. Answer my question. You take w or t equal to anywhere substitution equal to z square. Then w power n equal to z squared the whole power n. Check. Z squared the whole power n. Okay. Then you have to find the radius of convergence. Here r equal to 1. So radius of convergence is 1. So the mod z less than 1. So z squared mod z less than 1. So mod z is less than or equal plus or minus 1. So we take always positive, because z equal to 1 means root 1, not plus or minus 1, directly we write here, we take only positive value because radius is positive. So root 1, that's equal to 1. So here radius of convergence is 1. So using this method also you have to find the radius of convergence of this problem. Okay. The same property, why we cannot use the previous problem? Do you have any? Already we did 2 more problems. Yes. Why here we cannot use that property? Are you follow, ma?
Yes, sir.
Why we cannot use this property here? Yes, shall we use also here also? What is that property? Summation n equal to 1 to infinity an z power nk equal to, you have to find the radius of convergent r, that r power k. So what is the value of r here? What is the value of r here? R equal to r equal to 3. So r power k is 3 squared. Not 3 squared. n squared 2 power k. No answer, sir. Modulus of z minus 1 the whole squared less than r. So modulus of z minus 1 the whole squared. The condition is true for all the question, but here check it in the first one, then come to the second. You check whether here it is correct or not, then you move on this z minus 1 problem. Summation n equal to 0 to infinity 2 power minus n into z power n the whole square. So here the radius of convergence is 2. 2 for 2 is 4 is there. Again you go through it. Okay. This is z power n the whole power k, not nk. Appo nk and n power k is not equal. Okay. Are you clear, ma? Here nk, n by k is, I wrongly said that here nk, n by k is both equal. Nk, n power k are equal, but it is, I am wrongly said that it is wrong. Z power n the whole power k is different, z power nk is different. So that's why I am recalling the first two problems. I have some about explaining that. Now I have cleared. Are you clear, ma? So z power n the whole power k is different and z power nk is different. Here is z power nk. Summation n equal to 0 to infinity a n z power nk. So radius of convergence is r power k. So r power 1 by k. So here k equal to 2. Radius of convergence is r equal to 2. So 2 power 1 by 2, that's equal to root 2. Are you clear, ma?
Sir.
So same for problem 3. Here also you have using the same property. So for that reason only I have given this PDF. Z power kn equal to r power 1 by k. Z power n the whole power n is not given here. You change in your notes z power kn and z power kn the whole power n. Okay. This is here also k equal to 2. Your radius of convergence is 3. So r power 1 by k, that is 3 power 1 by 2, that is root 3. Are you clear now?
Yes, sir.
Okay. First, while I explaining the property, I make some mistake here. It is not this is n power k. Okay. This is nk, not n by k. Okay. Next problem. You didn't follow this procedure. Just you have to using that property. Just you have to check the option 3 is correct. Next 10th problem. Consider the power series n equal to 2 to infinity, because log 1 is 0, that's why we taking n equal to 2 to infinity. Log n x power n, the radius of convergence of power series is, directly we have to take a n equal to log n, all log n, 1 by r equal to a n plus n, log n plus 1 divided by log n. Directly we didn't simplify anything here. Okay. Then you apply the limit n tends to infinity, log infinity by infinity, it is the indeterminate form. Then you have to apply L'Hopital rule. Already I said L'Hopital rule. What is L'Hopital rule? You have to differentiate numerator separately and denominator separately. Then you have to apply the limit. Here also the Logic is that after simplifying the limit function we get indeterminate form. Whenever we get the indeterminate form while applying the limit, we using the L'Hopital, then we applying the limit, we get the value of a limit of function. So we applying the limit, we get indeterminate form. So using L'Hopital rule, differentiating respect to n in the numerator. So 1 divided by 1 plus n. In the denominator 1 by n. We simplifying this again, we get n by n plus 1. We take n is common outside. Simply we get 1 divided by 1 plus 1 by n. Then we applying limit n tends to infinity. This term becomes 0. So 1 by 1 is 1. So 1 by r equal to 1, r equal to 1, so option 2 is correct. Are you clear now?
Yes, sir.
Whenever you have occurred indeterminate form, you apply the L'Hopital rule, then you have to find the limit. That is one logic is there. Next, f is holomorphic function. Already we know what is holomorphic. In an open unit disk such that limit z tends to 1, f of z does not exist. Z tends to 1, f of z does not exist. Now remember that what is given, f is holomorphic on the unit, the domain is on the unit disk. That is d equal to set of all z such that z belongs to C and mod z less than 1. Okay, this is C, not R. That belongs to C. Such that mod z to 1, this is the domain is there, and f limit n tends to infinity, z tends to infinity, f of z does not exist. So you have to consider a function f of z as in this manner. Again, let n tends to infinity, 0 to infinity, a n z power n be a Taylor series of f above z equal to 0. So next, first one is f holomorphic. We have to define a function in this manner. Another one, we take one power series, and this is not a power series, be a Taylor series about f z equal to 0, and let r be the radius of convergence, means then the radius of convergence is what? Are you understand the question?
Yes, sir.
Okay. F is holomorphic. We want to define a function f. It is not defined at z tends to 1. Then we expand the Taylor series z equal to 0. Then we have to find the radius of convergence of the series, given series. Okay. First, our aim is to define a function that is a holomorphic and it does not exist z tends to 1. So for that I have defined one simple function f of z. This is our defined function f of z 1 divided by 1 minus z. It satisfies the first given two conditions. Check whether your function satisfies your given condition. First you check here, limit z tends to 1. Z tends to 1 means 1 minus 1, that is 0, that is infinity. It is does not exist. Okay, this rule is satisfied. And also this function is holomorphic except at z equal to 1. Yes, it is a holomorphic function except at z equal to 1. Are you clear now? Are you clear now?
Yes, sir.
Yeah. So from this we have defined one given function f. Then we find the Taylor series of f at z equal to 0. Okay. Anybody remember what is Taylor series? What is Taylor series, ma? F of z equal to
1
f of 0
f
plus f dash of 0 into z by 1 factorial plus f double dash of 0
double dash of
into
0 z
Z square will be 2 factorial, because we want to about Z equal to 0 means directly write Z, otherwise Z minus Z naught, Z minus Z naught the whole square. Here Z naught equal to 0. Okay, 2 factorial plus and so on. Here you finding the first derivative f dash and f double dash, f double dash up to etc. Then you have finding applying the Z equal to 0. The Taylor series expansion of f about Z equal to 0 is, here I directly written, if you want to find the Taylor series about this, you have to find using this manner 1 plus z square plus z cube plus up to etc. So this is summation n equal to 0 to infinity z power n. Are you clear now?
Yes, sir.
Okay. Next, we want to find the radius of convergence of our Taylor series about z equal to 1. That is clearly we say r equal to 1 because an equal to 1. an plus 1 limit n tends to infinity. Again we applying the, we get radius of convergence is 1. Are you clear, ma?
Sir.
So as f of z becomes a summation n equal to infinity zn, which has radius of convergence is 1, about the Taylor series, explaining the Taylor series about z equal to 0. Therefore option 1, 3, 2, 4 are incorrect, option 3 is correct. Are you clear? Here your an is directly not given. For an there is 3 condition is there. First one is you have to define a f that is holomorphic, and also that function does not exist at z tends to 1. So you want to define a function, that function satisfies our assumption. So I have to define the function f of z equal to 1 divided by 1 minus z. In my function satisfies these 2 conditions. After that I have to find the Taylor series of the function about z equal to 0. I have my f of z equal to 1 plus z square plus z cube up to etc. So this is simply written as n tends to 0 to infinity zn. Now finding the radius of convergence of the series, here an equal to 1. So if an equal to 1 means clearly we know the radius of convergence also 1. Therefore the radius of convergence of our given series is, so already so here we find the an using our assumptions f here and here. Using these 3 assumptions we finding the an. After that finding an, we have to find the radius of convergence of the series, then the radius of convergence is 1. Are you clear, ma?
Yes, sir.
Okay. So if you find an, otherwise we can't find the radius of convergence. So an is directly given, you don't worry, we have to apply the Helmholtz formula, directly you get the answer. There is only one logic, if you find 1 by r then convert into r. But an is directly not given, then have to apply the relevant given condition, you have to find the an. After finding an, you have to apply the Helmholtz formula, then you have to find the value of 1 by r, then you get, from that 1 by r you get the r. Shall we move on next problem?
Yes, sir.
So this is the last problem. So from this problem we have to wind up today's session. So which of the following statement are correct? This part C question, ma. Last time June 18 asked this question. June 19 and June 19 also there, part C question. So I didn't work that June 19 question paper. If you have time, you have to collect the June 19 and work out that question paper. So which of the following statement is correct? So we want to answer these type of questions. We have to remember all the properties. Okay, that's why I giving these properties. If ak is bounded, then n equal to 0 to infinity ak z power k defines an analytic function on the open disk. Is it correct or not? Is it correct, ma? Where I give bounded function? We have studied one condition, boundedness condition. Singularity, radius. Where we studied, ma? Bounded. This unboundedness. Okay, already I think we studied this property. Where I didn't get. If
Analytic
a
functions topic, sir.
when ma which where ma?
Analytic function topics.
Yeah, the whole one. Here region of convergence. You look here, region of convergence. The convergence for each at some region on the complex plane, the series converges everywhere inside the circle radius of convergence, circle of convergence. Otherwise, it is diverged outside the radius of convergence because the series is unbounded. The series is nothing but an. Are you clear, ma? If you find the circle of convergence, so radius of convergence is nothing but what? You have to finding the radius of convergence is 2 means you draw the circle with center at point at any point at 2 centimeter radius. Okay, that is the circle of convergence. This circle of convergence, every point in the sequence or series is bounded, because we are taking the modulus which is less than or less than the radius value. So that is bounded. Outside the circle, any point on the your series is unbounded. That is an is bounded inside the unit, inside the circle of convergence. So an is unbounded in the circle of convergence. So now we see this problem. If ak is bounded, then ak z power k defines an analytic function on an open unit disk. It is correct or not? This is true or not? Ak bounded, ma, then it is defines an analytic function because there exists one function, bounded function. The bounded function is analytic. Is it Liouville's theorem? Non-constant analytic function is bounded non-constant analytic function. Sorry, bounded entire function is constant. So the option 1 is true. Are you clear? This power series, it is bounded, it has a radius of convergence, so it defines an analytic function on the open unit disk. Next, option 2, summation n equal to 0 to infinity ak z power k defines an analytic function, so it defines an analytic function on the open unit disk. Yes, ak must converges to 0. It's always not true. It's true somewhere true, but it's not always true. Okay, here in the last example, your given function is holomorphic, that is a holomorphic, but your radius of convergence is 1. But here you get what? AK must converges to 0. So it is not always true, therefore option 2 is wrong. Can you able to follow, ma?
Sir.
Next, f of z equals summation n equal to 0 to infinity ak z power k and gk is another one power series. Two power series functions whose radius of convergence are 1. Both radius of convergence are 1. Then the product of g1 and g1 and f and g has another power series represented in the form on the open unit disk. Can you return the form is correct or not? From this property we take adding, we get minus minimum, multiplication, multiplication r1 and r2 which is greater than or equal to r. So using this property we have to say this is 1 and this is 1, so also this also the radius of convergence is 1, therefore it represents the power series on the open unit disk. Are you clear, ma? F is the radius of convergence is less than 1 and G is less than 1, and from my property multiplying the two power series, the radius of convergence is always R1 into R2 which is greater than or equal to R. Now here this is R1, this is R1, this is R2, we multiplying R1 and R2 equal to R, that is equal to 1. So this is on the open unit disk. Open unit disk nothing but mod that modulus value less than 1. So here also the radius of convergence, that is R, that is which is less than 1, therefore the option 3 is correct. Can you able to follow? From our property here we choose our answers. So that's why the properties are important to study. Are you clear, ma?
Yes, sir.
Okay. How to match the property here? Are you understand? How to match that property and how to choose that answer? Those things are very important. Properties are well known, or we know, but how to match that property here? That is a very important one. You have to understand all the words. This is an open unit disk. Open unit disk means the modulus of radius of convergence less than 1. So that is very important one. This is 1 and this is radius is convergent 1 and 1 1. So another our required power series also R, that is R less than also 1. So the option 3 is correct. So this is a way to match your property in your required answer. Then you have to finalize your options. Then f of, here I explained somewhat different type of examples, that explanation you have to check whether also. Here we take f of z equal to n equal to 0 to infinity a k z power k as radius of convergence is 1, then f is continuously on this domain or not. So now we take one analytic function f of z equal to 1 over 1 minus z, which is converges, radius of convergence is 1. Already we defined in the last example. So but f is not continuous at z equal to 1, but our domain is containing 1. Sir, you have to choose different f, it is true, but in this f is not true, but generalized this is true for all f, then only the option is true. But in my example this domain is not true, therefore option 4 is wrong. Are you clear, ma'am, what I say? You have to choose f in this manner. Your domain is not satisfied because function is not continuous at z equal to 1. But here given that f is continuous on z equal to 1. But you have to choose different f. For example, f of z equal to just we have to 1 by z. It is continuously on this domain. But in particular, the f is common. Choose any f, it is satisfies this domain, not general term, not particular term. So it is true for all f, then only we have to choose this is correct. This is not true for this f, therefore the fourth option is wrong. Are you clear, ma?
Yes, sir.
Okay. So for any doubts regarding this?
No, sir.
Okay, ma.